Welcome back to Global Education Zone, and today in physics class we'll be talking about an important topic in physics known as reflection. Now in this topic we'll be talking about what reflection is, the properties of reflection, which is also properties of light, and then we'll also be talking about rectilinear propagation and devices that apply reflection principles and other things, and also reflection of light by plane and curved surfaces and other things. So first of all, what's reflection? Reflection, as I explained earlier, is a type of phenomenon where light hits the surface and light bounces back in another direction. Now when the light hits the surface, there's what's called a normal. A normal is a line at 90 degrees to the plane of the surface. Now the angle between the normal and the reflected and the incident ray, that's when the light hits the surface, it hits it with a ray, and that is the incident ray. And then when it bounces back, it bounces off by a ray known as the reflected ray. So the incident ray and the reflected ray, they are both acting at this plane, and they have a normal between them. That's incident ray. And the angle between the incident ray and the normal is called the angle of incidence. The angle between the reflected ray and the normal is called the angle of reflection. Now that's the major things we're supposed to know about reflection. So reflection of light is the process whereby light hits a surface and bounces back. So it changes its direction. When the light hits a surface, it changes in direction. So that is the main thing you need to know, and also changes the paths of the light. So instead of going straight forward, the light bends and goes in another direction. So all the paths. Now basically, we know about that light travels as waves, right? Now those waves are transmitted, right, through a medium, as I explained earlier in one of my videos on the video on waves. So go and check that out. So I explained how light travels through a medium, and that the fact that it is projected, it is propagated through the medium. So now that propagation can occur in three different ways. It could be a parallel propagation. That's when it is going in straight, equally spaced lines. So those parallel propagation are something like this. So light is propagating parallelly. Now it could be convergent when it's moving towards the same direction. This is called convergent propagation, when all light is moving in the same direction. Then we have divergent propagation, when the light is moving in a scattering direction. Now when it's moving from a point to different other points. Now this divergent propagation, it is how your torchlight propagates light. Your torchlight and even the light of the phone camera, it propagates through the space. So that is divergent propagation is one very common medium. Divergent and parallel propagation are very common. Then convergent is less common. It's very less common, but it is applied in your convex mirrors and concave lenses, right? So it's applied in your, I think, mirrors and lenses, either concave or convex. We'll get there. So then next talk about rectilinear propagation of light. So rectilinear propagation of light is a process whereby light moves along a medium in a straight line. So it's a rule in light that light does not move in curves, light does not move in circles, light moves only in a straight line. So if you have a ray of light, it's moved directly straight, and it will be propagated along that line. And one application of this rectilinear propagation is that light can also form shadows and eclipses. Now for example, where we have the sun, imagine we have the sun here. Now this sun's rays, and this is the earth. Now if peradventure the moon comes between the sun and the earth, then this moon will disrupt the propagation of the light rays. So that means there will be a natural phenomenon known as an eclipse. So that means when this light is going, it will pass here, but no light will be able to pass through the moon, because the moon is an opaque object. So an eclipse and shadows occur when opaque objects stands in the way or direction of light rays. So that means around this region, there will be no light around this region. So, and if the object is big enough, there will be a penumbra and umbra region. So basically, if this moon is big enough, then we'll have something going like this. One going like this. Then we'll have one hitting just the top of the surface. Now this one, beyond the ones hitting the top of hitting the sides of the moon, they are the umbra, while the ones outside that is the penumbra. So it's just like a region of a partial darkness, and a region of total darkness. So those are phenomena that occur with light rays. So you can, if you want to know more about this, you can check your new school physics textbook or any other physics book you have in order to gain more understanding on this. But this is the adequate knowledge you should have of that. So, and shadows, when you have a light moving direction and you have something here, that shadow will be cast. So the shadow will look something. The shadow will be resembling the object. So that shadow, it is the amount of light that has been cut off, the amount of light that has been absorbed or that has been deflected. So those shadows are formed when light cannot pass through an object. So it forms a void. So but the remaining light will pass through the surrounding space. That's why there's a region of dark and light. Now, talking about that, we have other areas to include in this video. Now, next we have to talk about, we'll move to magnification. Now, before that, we have to talk about a pinhole camera. A pinhole camera is a device, just like a box, which has a pinhole where light can enter. So, assuming there's an object outside the pinhole camera, now light from that object enters into the pinhole camera, and that light crosses over. So, and when it crosses over, it becomes inverted. So, in a pinhole camera, you have an inverted image of your objects. So that's one important property of pinhole camera. And pinhole cameras are a very good example, a very good example of what we call plane mirrors. So a pinhole camera forms an image, and the surface of that image formed resembles like a plane mirror. So, and the images of a plane mirror or a pinhole camera have 5 main properties. Number 1, they are inverted. So that means if you have the object erect, the image will be upside down. So it is inverted, it is not erect. So the image of, and for example, our eyes forms inverted image of object, but our brains turn the image back upright. So that is an example of how a plane mirror forms an image. So it's inverted. And number 2, it is also the same size as the object. So that's another property of images formed by plane mirrors. They are inverted, they are plane, they are the same size as the object. Now let me draw a plane mirror. Imagine this is a plane mirror now. So let's go away from cameras and let's go to the plane mirrors. Now you have the same object here. Now the image formed by the plane mirror will be laterally inverted. So that means if this side is, if there's something in this side, if there's something like a stick popping out from here, assume this is a lollipop and then you have a stick popping out from here, then when you look at it, the stick will pop out from the right instead of the left. So it's just as if you are seeing the left as the right and then you are seeing the right as the left. That's the difference. So in plane mirror, your image is laterally inverted. So but in your camera, the kind of inversion here is upright, is upside down. It's also laterally inverted, but it's upside down in your pinhole camera. Now next we have to talk about the fact that the image is the same size as the object. So now in a plane mirror, your image is the same size as the object. If your object is 10 meters tall, your image too will be 10 meters tall. And in addition to that, your object, that is the image of your object, is the same distance behind the mirror as the object is in front of it. So that means that this object appears to come from behind the mirror. So it's just if you are looking at something from behind the mirror is like the middle, is like at the middle between the object and the image. So if the image distance is A, then the object distance will be A. If the object distance is A, the image distance will be A. That's one property of images formed by plane mirrors. And lastly of all, they are not magnified. So they are erect and they are not magnified. So the magnification of such mirrors is 1, because there's no magnification, and there's no diminishing of the image. And so they are also erect too. So they are laterally inverted, they are erect, they are the same size as the object, they are as far behind the object as it is they are as far behind the mirror as the object is in front of it, and they are erect too. So that's for plane mirrors. And then I mentioned magnification earlier, right? So magnification actually refers to the ratio between the image distance and the object distance. So mathematically, magnification M is equals to V over U. So where your V is your image distance or your image size, while your U is your object distance or your object size. That's for magnification. Then we have different types of reflections. You know that the topic we are doing today is reflection of light rays, right? We have smooth reflection and we have diffuse reflection. So in smooth reflection, assuming there's light rays, there are a collection of light rays hitting the surface. So they will all be reflected in the same manner as they hit the surface. So this is called smooth reflection. Then for diffuse reflection, when you have light rays hitting a surface, something like this. So and this soft and when light hits a surface like this, and the angles are not uniform, they they are reflected from different angles. That is called diffuse reflection. So and the reason why diffuse reflection occurs is that the surfaces are not smooth. But in the case of a smooth surface, your reflection will be a smooth reflection. If it's not smooth, you have diffuse reflection. So I hope you've understood that concept. So moving on, we have images, the laws of reflection. So the laws of reflection of images. So now we'll talk about the laws of reflection. There are two principal laws of reflection. So the first law of reflection is that the angle of incidence and the angle of reflection are equal. So that means I is equals to R. That's actually the second law of reflection. The first law of reflection states that the incident ray and the reflected ray and the normal all lie in the same plane, and that plane is called the plane of incidence. So that means that's the first law, this is the second, and this is the first below it. So the first law states that the incident ray, the reflected ray, and the normal all lie on the same plane, and that plane is known as the plane of incidence. Now the second law says that the incident ray, the angle of incidence, is equal to the angle of reflection. So I hope you master that and you can apply it and recall it in your examinations. So next we'll talk about two different types of images. Now the aim of light is to form images, right? Light forms images, and those images, they can be of different types. Now the first type we're talking about is real images, and the next type is virtual images. Now real images are formed when you are seeing what actually is. So real images are images where light actually passes through the images and where they can be caught on a camera. Like something like images formed by a concave mirror, they are all real images because light passes through them and they can be caught on a camera. But images formed by convex mirror, they are not real because light does not pass through them and they cannot be caught with a camera. So now let's talk about parallax effect. So parallax effect is when you have two things in line and when they are not the same distance from an observer. If we have a marker here and I have my hand here and they are in the same plane with my eye, and then they are not the same distance from my eye. So there will be what we call parallax effect. So parallax effect is if those image lining they are in the same plane, right? So when I see one image, that means they are now on the same plane of my eye. But if they are not if they don't line, then they are not in the same plane. So I hope you probably observe that kind of thing when you make, some of you make toy guns, and when you might want to be shooting at insects or stuff, or maybe catapult. When you look at your stone is you want to wait till your stone is lining on your bed before you shoot. But at the end of the day, that stone will not hit the bed. So the reason for that is that there's parallax effect, because there's a distance between your two eyes. So what your first eye see as a straight line, your second eye might not view it as a straight line. So the best way of doing such thing is making use of a binocular. So a binocular is like a device that combines the two the binary vision of the eye into one and makes you see things. This kind of reduces parallax effect. So for parallax effect is the effect which is caused when two objects are not in the same plane of the observer's view, and also they are not the same distance from the object from an observer. So next we're talking about devices that apply or make use of reflection. So now there's what is called periscope. So and that periscope, it is like a device that applies light rays, and a periscope has two mirrors angled at 45 degrees to each other. So coming. So a periscope has two mirrors, and that periscope is used to see over walls, over barriers. So it makes you see 90 degree over walls, over barriers. Even it makes the observer see up to 180 degree. So it makes you see above and over barriers. So it looks something like this. It's a device that looks like this, something like a containment. So it has a mirror angle at 45 degree. Then it has another one angle at 45 degree. So then the viewing plane, this is the viewing plane. So basically, when images strike from here, they are reflected downwards. So when they are reflected downwards, so I guess it's something like this. something like this. So when they are reflected downwards, they kind of like hit this surface and then they are reflected. So and in this periscope, this is the angle, this is the normal. So this normal that is at 90 degrees to the surface. So I guess they meet at a particular point. So there is a real instrument that actually exists and makes you see above barriers. So you can check your books for that, for a more detailed drawing and explanation of how it works. But then moving on, we also have mirrors, and we have mirrors and we have lenses. But in this video, lenses has to do with refraction of light. But today we are dealing with reflection. So we'll deal with only mirrors today. So and then we have two types of mirrors. We have concave and convex mirrors. Now concave mirrors. Now before we delve into mirrors, we have to talk about the nature of mirrors. Now there are concave mirrors and there are convex mirrors, right? Concave mirrors are the type of mirrors that they form real images. Next, we're talking about the fact that concave mirrors and convex mirrors. Concave mirrors are mirrors that when they are formed, they curve outwards. Sorry, they curve inwards. The curvature is inwards. That's concave. That means they have something like this, and then the outside surface. So when light hits this concave mirror, you have something like the inner surface and the outside surface, right? So you have your focus and your pole. So we'll talk about focus and pole in some time later. But then the outside surface is silvered. So for this one, the outside surface is silvered and the inner surface is the reflecting part. That's for concave. Then for convex looks like this. So there are surfaces that kind of have a wider range. But this concave is inside. So then the convex is outward. So basically, but both of them have what we call focus and pole. So we'll take in concave mirror first. Now a concave mirror is also known as a converging mirror, and a concave mirror, it's a type of mirror that helps lights to come together in one place. So and it's used in when you want to make use of the sun to burn something, you want to concentrate a ray of light. So that's application of concave mirror. Then convex mirror, they are diverging mirrors. They scatter light rays, just like your torchlight. When you have something like a convex mirror that scatters the light across everywhere. So then we'll talk about concave mirror in detail now. So for concave mirrors, we have ray diagrams for concave mirror. I'll treat in the concave mirrors ray diagram. The first ray diagram for concave mirror is, we'll draw the concave mirror like this. This is the first, this concave mirror. So drawing the concave mirror, when you have your focus and your pole. So whenever you have an object that is behind, anytime you have an object, now these are the objects and image distances for when you have an object between your focus and your mirror. Now your focus is the point on your concave mirror, is a point that forms the part where it's kind of like twice, it's kind of half the radius of curvature. And radius of curvature is the radius of this arc. So as you've known, you should have known that your mirrors are formed from spheres. So and those spheres, when you cut over an arc of the sphere, the center of the sphere forms the C. Yeah, that's C. Sorry, that's the center of curvature, and then the focus is is half of the center of curvature. So from the mirror to the focus is half the mirror to the center of curvature. Now that focus is the point where the images, where the rays that are parallel and close to the principal axis, where they converge or where they appear to diverge. So that focus, they converge at the focus in the concave mirror, and they appear to diverge from the focus in the convex mirror. So now let's take concave mirror. Now when you have an object between the focus and the mirror, you have to draw a ray diagram, because any ray, we said that any ray that is parallel and close to the mirror always passes through the focus, right? So that means this ray, when a ray passes through parallel to the mirror, it will pass through the focus. Then we'll also trace it backwards, something like this. Then when we have another ray that passes through the center of curvature, it will pass through any ray that passes through the center of curvature let's trace it backwards. So this is where this ray meets is your image is where your image will be. And as you can see, our image is behind the mirror, and it is virtual because we have these dotted lines. So any image that's behind the mirror is always virtual. And this type of images, they are always they are always virtual, and in addition to that, they are erect and they are magnified. So when you have your image, your object between your focus and your mirror, your image will be virtual, erect, and magnified. Next, we talk about when you have your object on your focus. This is a concave mirror, but then you have your focus and you have your center of curvature. Then you have your object at your focus. So when you have your object on your focus, one ray will pass through the focus, pass parallel to the mirror, and pass through the focus. Another ray will pass through the center of curvature. Let me make the mirror, let me make it big enough. So another will pass through here, another will pass through here, and then match this way. So when you have your object at your focus, then your image will be formed at a parallel distance, and those parallel lines never meet, so they are formed at infinity. That's another property. Then when you have your image, when you have your object, sorry, this is your focus and this is your center of curvature. When you have your object between your focus and your center of curvature, then we'll draw a ray that is parallel and close to the mirror. And know that any ray that's parallel and close to the mirror will pass through your center of curvature, will pass through your focus, sorry. But any ray that passes through your center of curvature will pass through undiverted. It will not be bent. So now this one will be bent to pass through the focus. And then we have another one which will pass through the center of curvature. Center of curvature. So when it passes through here, they will meet at a distance which is beyond the center of curvature, and the image will be inverted. So your image will also be inverted if you have something like this. So and note, your image will actually be diminished, but in this drawing it is not drawn to scale. That's why it looks magnified, but your image is actually diminished. When you have your image between your center of curvature and your focus, your image will be diminished. It will be inverted, and it will be formed behind the center of curvature. Then next we have when you have your objects. Let's form the focus, and this is the C. Now when you have your object behind your center of curvature, so you draw a ray. Let's draw a ray to parallel and close to the mirror, passes through the focus. Let's draw a ray to pass through the center of curvature. So you see they join at a distance. So this distance is between the focus and the curvature and center of curvature, and then this image is also diminished. So actually, the image when it is between your center of curvature and your focus, it is actually magnified. But when it is between when the object is between focus and center of curvature, the object is magnified and is formed behind the center of curvature. But when it is behind the center of curvature, the object is diminished and is formed between the focus and center of curvature. So that is as far as I can go on concave mirrors, and those are the basic forms of image. Then lastly, you also have when the object is at the center of curvature. So you have F and you have C. So when your object is at the center of curvature, your image is one passes through the focus and one passes through the. So there's no one that passes through the C. But then when the image is parallel to the mirror, it forms at the focus, and when it passes through the focus, when it passes through the focus, it emerges parallel to the mirror. So this image distance is directly at C. So when your object is at C, your image too will be at C, and it will not be magnified. So that means you have a magnification of 1. It will be the same size as the object, but it will be inverted. Those are basic images for concave mirror. Then we have for convex mirror. So for convex mirror, there's only one basic image, and that image is formed always behind the mirror, and it's always virtual, it's always erect, and it's always diminished. So let's draw that. So now this is how we have these are concave mirror. Like it faces it has the expanding outside to us. So you can use this to remember, because when concave mirror are formed, this inside is the one that is where we have the image formed. But in convex mirror, we often have the image formed outside. So we also have the image formed inside in convex mirror, but it is the opposite side. So in your concave mirror, your images are formed the same side as the object, but in your convex mirror, your images are formed on opposite side of the object. So like look at all our images now are formed the same side, except when it is between the focus and the mirror. So this one is also formed the same side, the same side, the same side. So but in your convex mirror, when we have something like this, convex mirror, then we have the focus on the center of curvature. So if peradventure we have an object here, and when that object comes like this, it passes through the focus, then when the ray passes through the center of curvature like this, it goes undeviated. So then we have our image formed and it is upright. But as you can see, it is virtual because it's formed on the other side of the mirror, and it's erect and it's also diminished. So those are the major image object ray diagrams, and that is also the basics of optics in physics WAEC examinations. So thank you for watching, and in another video we'll continue this series.